Welcome back everybody. I am a teacher from Ilm Online Academy. In today's video, the topic is metallic elements and alloys. This is basically chapter number 14 of the ongoing series for the Cambridge Chemistry 0620, and in today's video we'll be having a look at the metallic elements and the alloys. So without further ado, let's just begin this. So first of all, I will tell you the contents which we will discuss in today's video, and the contents are the properties of the metals, second the uses of metals, and third alloy and their properties. So first of all, we will start with this one. You can see here on my screen, this is the layout for the periodic table. We have read a lot about the periodic table in our previous video of chapter number 13. So now we'll talk about metals and the non-metals today. So this is the layout you can see here on my screen. This is the layout of the periodic table, and through this I will show you the distribution of the metals and the non-metals in the periodic table. So you can see here, these are the metals. The blue colored are the metals, and the one which are in green, these are non-metals, and the one which have darker color, these are metalloids. So from the periodic table, almost 70% of the elements are the metals, and some are non-metals and other are metalloids. We have groups and periods in our periodic table which we read before. This is the first group, second, third, fourth, fifth, sixth, seventh, or group 8 or group 0. These are here periods, the horizontal rows. Total we have 7 periods in our periodic table. So most of the elements, 70 out of total 180 known elements, can be classified as the metals, and they are positioned to the left in our periodic table. As you can see here, metals are on the left of the periodic table, whose structures are held together by the metallic bonding. Metals have metallic bonding in their structures, and this type of bonding gives rise to many properties that metals have in common. So therefore there is a wide variation in the level of these properties when we look in detail at different metals. Metals like have high density, like iron. Iron is present in the center in the transition metals, so iron has high density, but alkali metals of the group 1 have low densities. So there is a variation and between the metals that are present in our periodic table. And now if we talk about the non-metals that lie to the right of the periodic table, here tend to have properties that are opposite to the metals. This transition from left to right is one of the major trends present in the structure of the periodic table, which we also discussed in the previous video. The trend or the change in the periods. At the start of the period we have metals, and as we go further or as we move further, we have non-metals at the end of the period. So non-metals form either simple molecular structure, like the first one, hydrogen. Hydrogen forms a simple molecular structure, H2. We have oxygen. Oxygen is also exists as a simple molecular structure, and sulfur also. Or we have some giant covalent structures in metals like carbon. In non-metals like carbon, and carbon have giant covalent structures. The giant covalent structures of carbon we have also read about that. The graphite and the diamond, the allotropic forms of the carbon, the giant covalent structure. This means that non-metals have a much wider range of properties, reflecting the wider differences in their structure. So we have also read about the bonding in the non-metals. Metals have metallic bonding, and non-metals have covalent type of bonding. So the best way to identify a metal or a non-metal is to check whether it conducts the electricity or not. The simplest apparatus for doing this, the test for the electrical conductive of a solid. We can set up a simple circuit, and a current will flow to detect by the bulb, and that can be measured by ammeter or any other device. So we have the metals which are present in our periodic table. All the metals will conduct electricity. So this is the first property of the metals also. that metals conduct electricity. I'm just talking about metals. In case of non-metals, they are opposite to the metal, so they will not conduct electricity. But metalloids have different structures, or they have the properties of both the metals and the non-metals, so we call it as the semi-metals. And even mercury, which is also liquid at room temperature. So I will tell you here one more thing, that we have two elements in our periodic table. We have mercury, and the second one is we have bromine. Both of these elements in our periodic table are present in the liquid state. Just these two elements in our periodic table exist in the liquid state at room temperature, right? So mercury is a metal and bromine is considered as a non-metal that belongs to the halogen group. So one metal and one non-metal exist in the liquid state at the room temperature. All the non-metals except the graphite do not conduct electricity. All non-metals do not conduct electricity, but there is just one except graphite. Together with the electrical conductivity, malleability, ductility, and thermal conductivity, all these and some other physical properties that are the characteristics of the metal, which we will discuss in today's lecture. So first is about the electrical conductivity, or to conduct the electricity. It is just the ability to conduct electricity, and electricity is conducted, ability to conduct electricity, and electricity is conducted in two ways. If any element or any substance has the free electrons, if free electrons are present there, then it can conduct electricity, like in case of metals. Metals mostly have free electrons, so that's why they can easily donate those free electrons and they can conduct electricity. The second major cause for the conduction of the electricity is that ions. If the substance is made up of ions, or if ions are present, then they can conduct electricity, like cations and anions. Like sodium forms the cations and chloride forms the anions. So this is about the electrical conductivity. Thermal conductivity. Next we have thermal conductivity. This is also the property of the metals, and therm means heat, so this is the ability to conduct the heat. Ability to conduct the heat, so metals have also this property. Next we will talk about the malleability and the ductility. Malleability is the ability of a substance to be bent or beaten into the shape. Like we can say that malleable is the word that is used to describe a substance that can be bent or beaten into shape. We can easily do this with the metals, like this is the property of the metals, that we can easily bend them or into different shape just for making any structures. And ductility is the ability of a substance to be drawn out in the wires. In case of wires, like we have, most of the metals are soft, so they can easily change their shape. We can easily bend them and change into shape in sheets. In the form of sheets, we have, this is the property is known as malleability, and if it is drawn into the wires, so you can say this property is known as ductility. And mostly if I give you the example of this, we have copper wires that are used for the conduction of the electricity. So copper metal is drawn into the wires, and ductile is a word that is used to describe a substance that can be drawn into the wire. So malleability, we have some examples of malleability, like aluminum foil. This is also the example, like that can be beaten or bent into the shape, into sheet like structure, that is known as the malleability. So these are the most common properties that metals have. So metals are very soft, like they can easily bend into the different shape. That's why metals are so useful for making things. They can also stretch into the wires, that is known as a ductility. So if a metal is subjected to a small force, it will stretch and turn into a original position. Like if we have, this is the structure of the metal. Suppose this is the structure of a metal before applying the force, and if we apply the force, and force will be applied here. When we apply the force here, then you can see here what will happen. Now you can see here when we apply the force. So this one you can see here before applying the force and after applying the force. If a large force is applied, the layers of the atoms slide over each other and they stay into the new position and new bonds are formed here, as you can see this one. So the new bonds are formed here, and now metals have the ability of malleability and also the ductility. Next, if we talk about the thermal conductivity, metals also conduct the heat well, and this good thermal conductivity results from, like you can see if I show you, this one is the metal and metal atoms are present there. These are the metal atoms that are present in this metal, and if we apply the heat at one end, heat is applied here at this end, the atoms that are present there, they vibrate. This area is hot and this one is cold, but due to the thermal conduction, what will happen? Just because of the thermal conduction, the atoms that are present there vibrate, and the increased vibration of the metal atoms where the metal is heated is passed throughout the whole structure of the metal. So that's why metal conducts heat very well. So the giant metallic lattice of structure means that they are good conductors of heat and electricity. Faster vibrating atoms collide with the slower vibrating atoms and heat will be conducted through the metal. And now we'll discuss about the physical properties of metals and also with the non-metals. Like basically we will compare the physical properties of metals and non-metals. So these are the important physical properties, and now we will see how the properties of metals and non-metals differ. So first property is thermal conductivity. Metals are the good conductors of heat, so they have this property. And if we talk about the non-metals are generally poor conductors or thermal conductors except diamond, which conduct heat strongly. So they are poor conductor, and there is one except, that is diamond, because diamonds strongly conduct the heat. Metals tend to be good conductors of heat, whereas non-metals are not. They are not good conductors of heat, or they are not good thermal conductors. And next, this is because metals contain the delocalized electrons that are present in it and that are free to move around to carry thermal energy or heat from one place to another. That's why metals are good conductors of heat. Next we have electrical conductivity. In case of electrical conductivity, metals, all the metals are good conductors of electricity, so metals are good conductors. And if we talk about the non-metals are generally poor conductors of electricity except for the graphite. They tend to be insulators. Non-metals are insulators, and just except graphite, because graphite can conduct electricity. Just like diamond, from all the non-metals, diamond can conduct heat or is a thermal conductor. So just like that, all the non-metals are insulators except graphite, because graphite can conduct electricity. And And next we have this is also because metals contain the delocalized electrons that are free to move. That is the reason behind it, and around to carry charge from one place to another. So that's why they have the good electrical conductivity. Next we have melting and boiling points. Metals are usually solids except for the mercury, which is liquid at room temperature, so they have high melting and boiling points just because the reason is they are solid. So just because of its solid structure, they have high melting and boiling points. They require more temperature to convert it into the liquid state or into the gaseous state. Next, in case of non-metals, we have non-metals are solids or gases at the room temperature except for the bromine. Bromine is a liquid, so their melting and boiling points are often low. They are often low because most of them are solids and or gases at the room temperature. That's why gases also have the gases require much low temperature for converting into the vapors, so that's why. Metals generally have high melting and boiling points, and this is because metals are giant structures with strong metallic bonding. There is strong electrostatic attraction between the positive metal ions and the negative electrons, so require a large amount of energy to break or to overcome the bonds and to change the state. Next, malleability and ductility. Metals are malleable and they are ductile, means they can be able to bend and shaped easily, and ductile means to stretched and pulling without breaking into the wires. So this is because metals, positive metal ions are arranged in uniform rows in the structure as I show you here. So metal ions are arranged in a uniform rows in a structure, so they can able to slide over each other, so that's why they are malleable and ductile. And next, if we talk about the non-metals, non-metals are not malleable, they are brittle, easily break when hit. Because they are brittle, so they can be easily breakable when they hit. So they are not malleable, they don't have the property of malleability and ductility. Next, hardness and strength. As metals are solids, so they are usually strong and dense. Metals are strong and metals are dense, and when a force is applied, they are hard and do not shatter, means they do not brittle, but they slide over each other. Next we have in case of non-metals. Non-metals are softer than the metals. They are softer than the metals, but diamond is very hard. Their densities are often low. Non-metal densities are low because they are softer than the metals, and metals are strong and dense, so they have much more density. There is just one except non-metals, we have diamond. Diamond is very hard. Next we'll talk about the sound. Metals usually produce a ringing sound when they struck, so we can call it as sonorous sound. A specific sound is produced when metals hit. They make a ringing sound. Sonorous is a word that is used to describe a metallic substance that rings like a bell when hit with the hammer. And non-metals are not. They are not, or they do not produce the sonorous sound. Next we have last, color and appearance. Metals are grain color except the gold and copper, and they can be polished. Mostly metals are gray in color, but except gold and copper, because they can be polished. Metals can be polished and except gold and copper. Next, non-metals can vary in color. They often have a dull surface when solid, so they vary in color and they have dull surface. So these are the physical properties, and now here we will see how the properties of the metals and the non-metals differ with each other. So now we'll talk about the general chemical properties of the metals, limited to their reactions with the dilute acids, with cold water and steam, and third one with the oxygen or with the air. So now we have the chemical reactions of the metals. So these are the chemical properties of the metals limited to their reactions. So first of all, we will discuss the reactions of the metals in dilute acids. So we are using dilute acids here for the reactions of the metals. We have also read about the reactions of the metals in the previous chapter. So in dilute acids, when a metal reacts with a dilute acid, what will happen? We have metal plus acid. This is the journal reaction, and when they react with each other, they produce the salt, plus we have a gas that is known as hydrogen. So this one is the journal reaction of any metal which reacts with the acid to produce the salt plus the hydrogen gas is formed. So this is also known as the displacement reaction, as metal is more reactive than the hydrogen that is present here and in the reactivity series. So the metal ions will displace the hydrogen ions in the acid to form a salt. For example, we have sodium metal. Sodium that is represented by the symbol Na, that will react with a dilute hydrochloric acid. So after reaction, as we have this metal, why we call it as the displacement reaction? Because it displaces other element in the acid, which is hydrogen. Metal is more reactive than the hydrogen, so it can easily replace the hydrogen, because sodium has much higher place in the reactivity series as compared with the hydrogen. So sodium can easily replace the hydrogen in hydrochloric acid, and it will form a salt, that is sodium chloride, plus we have hydrogen gas that is released. So this equation is not balanced. So first we will balance this equation. We have 2 hydrogen on the right side, so you have to write the 2 before the hydrogen. So for doing this, you also have to write the 2. You also have to write the 2 before the NaCl, because we have 2 chloride ions on the left side. So before placing the 2 in the coefficient with the sodium, so now this equation is balanced. So metals that are less reactive than the hydrogen will be unable to displace the hydrogen, so they will not form a salt. But here we are talking about the metals which are highly reactive than the hydrogen in our reactivity series. So this is the reaction of the metals with the dilute acids. After doing or after explaining all these reactions, I will also share with you the reaction of the metals in air, water, and also with the dilute hydrochloric acid of different metals like sodium, calcium, magnesium, of all in just tabular form. So first here, next we'll talk about the cold water and the steam. So this one is the second. So we have cold water and steam. When a metal reacts with the cold water, like H2O, which is liquid, so a metal hydroxide and a hydrogen gas is formed, and the general equation for this one will be, we have metal plus a cold water. And in case of a water or a cold water, what will happen? After reaction, we have metal hydroxide, because water has 2 types of ions. Water has hydrogen ions and water has hydroxyl ions. So these 2 types of ions are present in the water. So metal will react, as metals have positive charge, metals are cations, so they will react with the anions. Hydroxide ions will react with the metal and they form the metal hydroxide, plus we have hydrogen gas that is released. So this is the general equation. You can apply this equation with any metal that we will use. So the more reactive metals will react with the water more vigorously and quickly, like potassium reacts with water, it burns with a lilac flame, and it's a very exothermic reaction. So but whereas less reactive metals react with water less violently and more slowly. So now I will show you the example, like potassium. When potassium reacts with the water, what will happen here? After reaction, we have metal hydroxide. Potassium will react with the hydroxide ions that is present in the water. KOH plus hydrogen gas is released. So we will balance this equation also by placing the 2 in the coefficients. So when a metal reacts with the cold water, what will happen? Metal hydroxide is released plus hydrogen gas is released. The more reactive metals will react more vigorously and less reactive metals will react less violently. I will also share the list of the reactive metals and the less reactive metals. So next, this is the reaction with the cold water. Next, we will talk about the reaction with the steam. If we have steam here, steam, that means that has much higher temperature as compared to the cold water. So when a metal reacts with the steam, a metal oxide and hydrogen gas is formed. Metal plus we have steam. We are talking about the steam of the water. So when metal reacts with the steam, we have metal oxide. So this is the difference between them, that when metal reacts with the water and if metal reacts with the steam, that metal oxide and metal hydroxide. As you can see here, we have metal hydroxide in case of cold water and metal oxide is produced in case of steam or hot water. So this is general equation. And the example will be, we have magnesium metal that will react with the steam or water. Now we have the water that is present here in the gaseous state. Now you can see here, this is the steam, gaseous state is present here. In the previous, you can see here water is present in the liquid state because we are using here the cold water, right? So in case of steam, the physical state of the steam will be gaseous, and in case of cold water, it will be liquid. So from the equation, you can easily identify this by checking the physical states. If the physical state of water is gaseous, that means the reaction is with the steam, and if the physical state of water is liquid, then the reaction will be with the cold water. So when solid magnesium react with the water or steam or gaseous state, what will happen? We have magnesium oxide, that is the solid form. Magnesium oxide is produced, plus we have hydrogen gas. So this is the reaction of the metals with the cold water and also with the steam. So this is how the metals react with the cold water. Next, we'll talk about the third type of reaction of the metals with the air or oxygen. When metals react with the oxygen, a metal oxide is formed. Oxide is the word that is used when oxygen is attached or when oxygen is added to any compound. We have a specific word that is known as oxide, like carbon monoxide, carbon dioxide, sulfur oxide. So when oxygen is added to any element, we call it as oxide. Oxide is a word that is specific for the oxygen, or if oxygen is attached to any element. So when metal reacts with oxygen, a metal oxide is formed. The speed at which this reaction occurs, it depends upon also the reactivity of the metals. If it's highly reactive metal, so the metal will be done more quickly or more vigorously as compared to the less reactive metal. So the general equation for this one will be, we have metal plus oxygen that will react. So the speed of the reaction depends upon the reactivity of the metal. We have metal oxide that is released after reaction, just one product. Example will be, we have calcium metal that will react with the oxygen gas, and when it reacts with the oxygen in the gaseous state, we have calcium oxide that is released. So this is the metal oxide. This equation is not balanced. We can balance it out by placing the 2 before the coefficients. So when a metal reacts with the oxygen, a metal oxide is formed, and the speed at which the metal or the reaction occurs depends upon the reactivity of the metals. So now I will show you some metals with their reactivity, like we have the reaction of the metals in the air, water, and also with the dilute hydrochloric acid. So these are the metals. We have sodium metal, we have calcium, magnesium. I'm showing you the reactivity of the metals. We have aluminum, we have zinc, iron, lead, copper. So these are the metals. If I show you the reaction in the air, oxygen and water, the reaction in the air, water, and with the dilute acid. So now I will show you separately the reaction of these metals in these three different states. So what will happen in case of sodium, calcium, magnesium, these three metals, when react with the air, what will happen? They burn very strongly just because of its reactivity. They are much stronger, they have more reactivity, so very strongly they react, and when they react very strongly in the air, they form oxide because oxygen is present there and oxygen combines with these metals. And if these three metals react with the water or with the cold water, they give hydrogen gas. Hydrogen gas will be given off when they react with the when they react with the water. And in case of dilute acid, they react very strongly because they have much reactivity. So just because of that, they can react very strongly with the dilute acid, and they also give hydrogen gas in this case. Next, if we talk about aluminum, zinc, and iron, these three metals, aluminum, zinc, and iron, they burn less strongly as compared to the upper metals because they have less reactivity than calcium, magnesium, and sodium. So they burn less strongly in the air to form the oxides. They also form oxides, but the reaction is less stronger or much stronger as compared to the upper metals because they have much more reactivity. Next, if we talk about the reaction with the steam of these metals, then when they are heated, they give hydrogen. They show the reaction with the steam, not with the cold water, like when they react with the steam or when they are heated, they give hydrogen. So hydrogen is given off when they react with the steam. Third, the reaction with the dilute acid, they react less strongly as compared to the upper one because sodium, magnesium, and calcium have more reactivity and they react more strongly, but they have less reactivity as compared to the upper metal, so they react less strongly to give the hydrogen ions. And these reactions in which aluminum is present only occur, or you can say that if the protective oxide layer is removed from the aluminum, because aluminum resists corrosion. So if we remove the protective oxide layer, then these reactions will only occur in case of aluminum because aluminum resists the corrosion and forms the protective layer on the upper side. So next we have some more metals: lead, copper, we have silver, and also we have gold. So if we talk about the reactions of these, lead and copper, these two, what will happen? They react slowly react because they have much less reactivity as compared to the upper. So react slowly to form the oxide layer when we heat them. And in case of the reaction with the water, do not react with the water. So they do not react with the water because they don't have much more reactivity. And also with the dilute acids, acid is also not concentrated, it's dilute, so they will not react. And in case of silver and gold, they do not react with the water, air, or also with the dilute acids. That's why we can use the silver and gold in jewelries in different travel. You can use there for making jewelries, right? So that's why, because they do not react with the water, oxygen, and also with the dilute acid. So these are the reactions of the metals with the air, oxygen, with the water, cold water, or with the steam. And third, we talk about the reactions of the metals with the dilute hydrochloric acid. Next, we'll talk about the uses of metals. So the next content is uses of metals. We'll describe here the uses of metals in terms of their physical properties, including physical properties which we read before. The first one is metals are good conductors of heat and electricity. So they are conductors of heat and also electricity. Second, based upon the malleability and ductility, means to be bent into the shape or drawn into the wires, that is ductility. And third physical property which we will include here, as some are very shiny, some metals are very shiny, so we can also use this property here. Some have low density, so we can use that in making various products, low density, or some are resistant to the corrosion. So that's why, like aluminum is resistant to the corrosion, so you can use it at that where to resist the corrosion. Metals have a variety of uses due to their physical properties, which we have read before, such as, first of all, if we talk about the uses of metals, first, if we talk about aluminum metal first. Aluminum was for a long time an expensive and a little used metal. So aluminum is light, strong metal and has good electrical conductivity. It's light. Aluminum is light in weight and it's a very strong metal, so you can use it at various purposes, and it has also the good electrical conductivity. Increasingly, aluminum is used also for construction purposes. It is used in the construction of some naval vessels and modern cars. It is commonly used in aeroplanes, where it is usually alloyed with the other metals such as copper, and its low density and good conductivity have also led to use in the overhead power lines. So aluminum is very resistant to the corrosion, and its low density prevents the sagging of the cables between different pylons. So you can use the aluminum at different various for making various structures. Aluminum is particularly useful because it's protected from corrosion by the stable layer of aluminum oxide. What will happen if aluminum is exposed to the oxygen and the water? It will form a protected layer. A protected layer will be formed on the upper surface. How the protected layer is formed? By the reaction of aluminum with the oxygen, as Al2O3 is produced. This is the stable layer of the oxide that forms on the surface of the aluminum, and it will protect the underlying metal. So this protective layer stops the aluminum from reacting. This makes aluminum foil containers ideal for food packaging because they resist the corrosion by the natural acids present in the food. So aluminum is also used for external structures like window frames because the metal also resists the weathering. So the first use which we have discussed here of aluminum is that aluminum metal is used for the manufacturing of aircrafts, and it is also used as a alloy in aircraft with the copper because of its low density. So you can use the aluminum. It has low density due to lightweight atoms, and making it an ideal material for manufacturing aircraft structure at its lightweight and easy to bend. Second, it is also used in the electrical cables. Because of its low density and good electrical conductivity. Low density aluminum is lightweight and easy to move around. Good electrical conductivity, delocalized electrons are free to move around and they carry the charge. So that's why we can use the aluminum for electrical cables. Third, you can use here for the packaging of the food. Have you ever heard about the aluminum foils which we are using for wrapping of the food? So aluminum is used in food containers because of its resistance to the corrosion. Resistant to the corrosions, as we have discussed here, aluminum forms the upper layer of the aluminum forms the aluminum oxide, that is the stable form, and it reduce further oxidation or corrosion to the underlying metal. So aluminum is used in the food containers. Next we will talk about the other metal, which is copper. As copper is used in electrical wiring. This is the most important use of the copper because it has the property of ductility, so we can use it in the electrical wire. We have copper wires for the conduction of the electricity. Delocalized electrons are free to move around the copper wire and they carry the charge. Ductility, just because of its property of ductility, we can easily convert the copper metal into the electrical wires, so they can be able to stretch and drawn out through a wire without breaking around. So that's why we can use the copper here. And copper has also the distinctive color, and it's one of the least reactive metals in common use. So we can also use copper for water pipes and also for roofing of the buildings, as it's least reactive. So that's why you can use as a water pipe, because it will not react with the water, so you can use there. Copper has high electrical conductivity, so we can easily drawn into the wire, and this is the most major use of the copper here in the electrical wiring and domestic wiring, in electrical cables. It is also used in circuit boards of the smartphones and also in some other electronic equipment. The copper used for wiring and circuit boards are made up of much high purity, like we made it 99.99%, or the electrical conductivity will be reduced significantly. So that's why copper is refined to a very high purity by the process of electrolysis, just to make it high purity of 99.99%, or the electrical conductivity will be reduced significantly. So this is the major use of the copper in the electrical cables and also in the domestic wiring. Next we will talk about zinc. The key properties for the zinc include it forms a protective coating on the iron and also on the steel objects. So it is, like you can say that it forms a protective coating on iron and also on the steel objects, just to prevent them from the corrosion, because it's very easy to for the iron to corrode, so it can form the protective coating. Zinc can form the protective coating on the iron and steel. You have also heard about the sacrificial protection. So zinc here acts as a sacrificial protection, or it gives the sacrificial protection to the underlying metal that is present there. So it forms a protective coating on the iron and some also the steel objects. So these are the key properties for the zinc. And if we talk about its use, we can use the zinc in galvanizing iron. For the galvanization of the iron, you can use the zinc, because iron easily corrodes away. That's why zinc is applied as a protective coating on the iron, and steel just to prevent the corrosion. So that's why you can also call it as the sacrificial protection that is given by the zinc. So for the prevention of the rusting, it forms a protective layer on the iron and also on the steel objects. Next we will talk about the last one, which is iron, uses of iron and also the key properties. Iron. Iron is hard but brittle, and it is now replaced by the steel, and it is also a good conductor of electricity. It's hard but brittle, so now it is replaced by the steel. The famous if we talk about some bridges, the famous bridges like the Iron Bridge, that was first tower bridge that is built of the iron and awarded world status also. So it has a span of around 30 meters, so you can use the iron, or we use the iron there. Iron is moderately reactive transition metal. By itself, pure iron is very soft and weak, and therefore not very useful for the construction. So you can we have cast iron that is obtained from the blast furnace and can be used to make the large objects such as the bridge structure or the iron bridge, which I talked about earlier. Cast iron was used in the rail. So we have cast iron that is produced from the blast furnace, or obtained from the blast furnace. We will talk about more of the blast furnace in chapter number 16. So cast iron was used in rails, in boats, and also it is used in many buildings. As well as in iron cylinders and steam engines. Iron production and use was central to the Industrial Revolution, using new manufacturing process. And cast iron can even be used in making cooking pots and pans, as it conducts heat very well. So you can also use there in the cooking pots. And the use of iron is smaller and more sophisticated pieces of was restricted, as it was too brittle, and just because of it is too brittle, so that's why it was restricted. And the high level of carbon in the cast iron is 2 to 4%. 2 to 4% of carbon is present there in the cast iron, and just because of that it disrupts the lattice structure of the iron and makes the metal liable to shatter when too much force is applied. So the metal is too brittle. That's why the metal is brittle. And the strength of the metal or the iron can be removed by adding the amount of carbon present there, or by adding some other metals just to create the different forms of steel to match the use that we want. And next, so these are the key properties. Iron can be used in the construction girders, in large casting, and also in the cooking utensils. So these are the properties and uses of some major metals, and we have also summarized here some of the major uses of some metals and properties that most of the metals have. Next, we will talk about the alloys and their properties. So first, describe an alloy as a mixture of a metal with other elements. This is the mixture of metal with the other elements, just to increase its properties or enhance its strength. The alloy are the metal compounds that are made by combining a metal with other elements, and this process can be carried out to give the metal greater strength and also for the resistance to the corrosion. So it gives us greater strength, like in as we already read about aluminum. Aluminum alloy can be used in the manufacturing of the aircraft. Aluminum is alloyed with the copper because aluminum has much lower density, it's lightweight, so you can add the copper. So a mixture of metals with the copper and aluminum can form the alloys. We have some examples of alloys also. In the examples, we have a brass. Brass is an alloy, and it is a mixture of copper and zinc. Copper and zinc is present. Two metals are present there in the brass. We have steel, stainless steel. Stainless steel is also an alloy, and this is a mixture of iron and some other elements like chromium, nickel, and carbon. So these are present there in the stainless steel. stainless steel, we made the stainless steel or this alloy just to prevent or resist the corrosion and also to give the greater strength. So now alloys generally have greater strength and hardness than as compared to the pure metals. Pure metals are soft, they can easily slide over each other. So in case of the alloy, as we have the mixture of some metals, like in stainless steel we have iron, we have carbon, nickel and chromium. Carbon is a non-metal, so we can also use a mixture of metal and a non-metal in case of alloys, just to increase the strength and also the resistance to the corrosion. So their utility in the manufacture of the end material is also varied, like stainless steel is much harder than the pure iron, which is very soft. So just to increase in its properties or in its just to gain or have the greater strength, we are using or we make the alloys. Next we'll talk about the uses of alloys in terms of their physical properties. Alloy can be used to make a variety of tools. You can make so much tools from the alloys as opposed to their pure metal counterparts, because pure metals are much softer, so pure metals are not used for making tools. So due to their hardness and resistant to the corrosion or rusting, we can use this. Corrosion is destruction of the materials by the chemical reaction with the substances that are present in the environment, like moisture and oxygen. So iron rust when there is a presence of oxygen and water. So to make the cutlery, you can use the stainless steel. You can't use the iron because it's more exposed to the water, moisture, oxygen. So for making the cutlery, stainless steel is mostly used, and this stainless steel is an alloy and that resists the corrosion and greater harder strength, you can say that, than the pure iron. So we can use the alloy in different structures. Next I will show you here the representation of the diagrams of the alloys from their structure. Like suppose this is the pure metal, like this one. These are the atoms that are present in the pure metal, like copper. Suppose the same type of atoms are present in the pure metal, and this one is pure metal, pure copper metal. And here we have the representation of the diagram of the structure of brass, which is an alloy of a zinc and copper. So these are the copper atoms that are present there in case of brass. And we have a zinc, like this. So this is the alloy that is present there. Alloy is a mixture of metals, and alloys are compounds that are made up of two or more elements, so the size of atoms are different, so layers will be distorted. There is no specific layering in case of an alloy, and the structure of the pure metal has neat layers of identically sized metal, but not in case of the alloy. Next, we can also explain in terms of the structure how alloys can be harder and stronger than the pure metals, because different size atoms are present in the alloy mean the layers can no longer slide over each other. So in case of alloys, no sliding movement because of different sized atoms that are present there. No sliding, different atoms are present there, so that's why alloys are much stronger and harder than the pure metals due to their difference in the structure. And the difference between them is that pure metals have same sized atoms. Same size atoms are present in case of pure metal, so they can easily slide over each other, but that is not going to happen in case of the alloys. So layers can easily slide over each other, and they are soft and they are malleable, pure metals. But in case of alloys, we have different sized atoms. In case of alloys, different size of atoms are present there, because different atoms form the alloys, or it's a mixture of the different atoms. So alloy have different atoms, different sized atoms, you can say, metal and a non-metal atom, so the layers are unable to slide. No sliding movement will be there. They will distort if we apply the force, and they are more hard and they have more strength as compared to the pure metal. So these are the properties of the alloys and their structures. We have also read about the alloys, metals, non-metals. So this is all about chapter number 16, which is metallic elements and the alloys. And next, now I will show you here some important alloys. We have brass. Brass is an alloy, and brass is a mixture of copper plus we have zinc that is present there. 70% copper is present there in case of brass, and in zinc 30% zinc is present in brass. So 70 plus 30 we have 100%. So this mixture or this alloy is much harder than the pure copper gold colored musical instruments. So you can use there in musical instruments, ornaments, and electrical connections. So brass is there. Next we have bronze. Bronze is also a alloy. Bronze is a mixture of copper. We have 90% copper that is present in the bronze, and 10% tin is present there, and you can use it in statues, in bells, in different parts of the machines. Next we have stainless steel. We have stainless steel, and stainless steel is the alloy that is made from the iron. We have iron, we have chromium, we have nickel, and sometimes carbon is also used. 74% iron is present there in stainless steel. We have 18% chromium, and we have 8% of nickel is present there. So you can use it in making cutlery because it does not rust. We can use it in surgical instrument, in reaction vessels, in the chemical industry. So these are the uses of the stainless steel alloy. We have another alloy, that is solder. Solder is also an alloy, and it has two elements like tin we have, and also we have lead. The tin that is present there is 50% tin, and 50% lead is present in case of a solder, and it has a lower melting point than either tin or lead, so making it useful for the electrical connections. So these are some important alloys that you should know about. We are done with this chapter number 16, metallic elements and the alloys. We read about the metals and the non-metal, the distribution of metals and non-metals in the periodic table, and some properties related to the metals and non-metals. Next we talk about the uses of metals, and in the last we read about the alloys, that are the mixtures of metal, and their properties and also their uses. So this is all about today. Hope you understand all this. If you have any question, you can ask in the comment box. If you like our content, then please subscribe our channel. We will meet in the next video.